Well, back in the 40s in Massachusetts, I think there was legislation that was brought up to try to ban radios in cars because they thought they would be too distracting because people would sing while they drive. And somehow we managed to get through that. So who knows? Maybe, maybe Google Glass is the answer. Next up is Danny Shapiro from NVIDIA. Come on up.
Yeah, thank you.
Thank you.
Do a switch.
Yep. Change here and.
Yeah.
Let's move this out of the way for you. I swear I should be saying something witty, but I don't have anything.
It's good. Been here all week.
Tip your waiters and waiters.
All right, let's see what happens here.
Good start.
It is a good start. We're going to talk about the Galaxy. That's not such a good start. Let's see if we can fix that. Did you guys, can you adjust it from your side? If not, I can try to do something. Oh, here.
I think it was.
All right. It's gonna. Okay, great. So, thank you for allowing me to address you here and for the invitation. It's an honor to be here. I'm from our headquarters out in Santa Clara, California, so heart of Silicon Valley. I get to see some of these Google cars driving pretty much every day up and down Highway 101. Before I get started, how many people are familiar with NVIDIA, who have heard of NVIDIA? Okay. If you're at MIT, put your hand down, and now let me see who else. So we're a technology company, and really we're best known for inventing the GPU, which is the graphics processing unit. Not to be confused with the CPU, the central processing unit, but basically our technology goes into your PCs, into your laptops, and your workstations, phones and tablets. A fundamental difference here is that the GPU is a many-core device. You've probably heard of your CPU being a dual-core or a quad-core. And think of it as lanes on a highway. You have a 4-lane highway for data to get through and for you to process that information. Our GPUs today have over 2,800 cores on them. So it's really the world's most sophisticated processor. Billions and billions of transistors go on these chips. And as a result, we can create beautiful visuals, all the graphics that you see, whether it's you're doing engineering work or you're watching visual effects for movies. But also these GPUs are used for all types of other processing. And many of the things Peter was talking about today in the design of the car are covered. But what I wanted to do was spend a few minutes and really talk about the differences between computers and cars. Obviously, they're very different, but we're seeing a lot of these technologies converge. The making of a PC or a tablet or something like that is relatively simple. You're assembling maybe 100 parts. A car, you're assembling thousands and thousands of parts. Right? It's a very complex system. If we just focus on the technology going into the car, however, if you look at the PC and the computer market, it's really this kind of more standardized modular architecture that we've been able to really build on in the industry year after year after year. We're not scrapping it each time we come up with a new design, but it's very iterative. Whereas within the vehicle life cycle, every 5 to 7 years, like the whole technology architecture gets thrown out and new ones were created. And in fact, every brand seems to have their own architecture. There's no standardization between different car manufacturers. So the design cycles are much longer. And I think this is where the auto industry has had a struggle, basically. As technology evolves so quickly, you buy a brand new car, and all of a sudden, you realize the technology in my brand new car is already out of date. A big part of this is software as well. And we see in the computer industry how software reuse is just constant. We're able to leverage a lot of the technology investments we make year after year after year instead of having to recreate stuff from scratch all the time. And the other thing we've seen now in the last several years, as everyone now has smart devices, these devices are getting updated while they're on your desk. Over-the-air updates have enhanced then the life of those products, made them better over time. And we really haven't seen anything like that in the car space until very recently. What I'd like to do is spend the next couple minutes just talking about visual computing and what that means and why that's relevant to everything we're talking about, what Brian was talking about and what we'll be covering later. Visual computing is what we focus on. It's about creating images, first and foremost, and it's really driven by the gaming industry. That's where our company started over 20 years ago, video games. And who knew that this industry would just blow up, literally and figuratively, right, in terms of revenue and importance of this plays in so many people's lives. The gaming industry, multi-billion dollar industry. It's not unheard of for a brand new video game on its opening weekend to generate over $1 billion in sales. So this has really driven a lot of the research and development technology in computer graphics. From there, of course, there's a whole professional side of graphics and visualization. And we work extremely closely with basically every automaker on the design of their vehicles and the engineering of their vehicles, the CAD, styling. What we wanted to do was be able to showcase the fact that gaming here has moved from this kind of world into very realistic graphics now and the ability to render in real time. So inside the car now, we have the ability to leverage visual computing and to see how these graphics are used for styling and design and simulation, all kinds of engineering for interactive point of sale. And basically the ability to do everything in the design cycle. Again, whether it's the kinds of things that we would see in visual effects, to CAD for vehicles, to the design and styling, and simulation. Computer graphics and visual computing are used extensively in automotive, as well as in the whole side of interactive point of sale. So in Silicon Valley, again, where we've been focused, it's about creating computers. And now we're bringing this computing technology into the car. The way to do that now is to leverage supercomputers. A lot of the GPUs today are being used in supercomputing centers. All of these cores that I've been talking about are being used to do high-performance computing, to be able to do high levels of number crunching, and to do that kind of simulation work. And now we're bringing that type of architecture down into a mobile computing device that goes into the car. The Titan supercomputer is our country's fastest supercomputer. It has over 18,000 of our graphics processing units inside of it to do number crunching. What we've done now is shrunk this down into a form factor that we can deliver an automotive-grade module into the vehicle. So this is what's going into cars today. This is what processes information at an extremely high rate. It can drive the screens in the vehicle, but also is being used to perform a lot of other computing functions. In this case here, this is an example of a system that Audi makes. So this is their MIB, or their multimedia infotainment system. This processor, which is basically a full computer, goes into that system, and it's modular. So it's upgradable. It can be updated via software changes throughout the life of the vehicle. And it also then provides the ability of being automotive grade. It differs quite a bit from what happens with your phone or your normal PC. So it's automotive grade technology that goes through an extensive amount of testing, and it can handle the harsh operating environments within a car. So this is what's used inside the Audi A3, and now moving throughout all the Audis, the Volkswagens, and the entire Volkswagen group. It's used throughout BMW's line, from the new i3 and upcoming i8 to the Mini and Rolls-Royce. And really now is evolving. If we look at what Audi Strategy is, creating digital cockpits then that visually are stunning, visually look like real elements, reduce that driver distraction because it isn't something that's hard to interpret, but instead the navigation or the ability to move things around is something that you can personalize depending on your needs. They've also then moved to creating experiences for the passengers in the vehicle by having a multimedia experience like an automotive-grade tablet. And then moving forward, taking the same technology, the newest generation, that they can put in their autonomous vehicle, or in this case, partially autonomous. So Audi announced at CES this year that they will be using NVIDIA technology hidden in the trunk to be able to take data and help these vehicles drive with no hands, no feet while you're in traffic on the highway, or to be able to park themselves in specific situations. So you can actually get out of the car, hit a button on the key fob, the car will park itself. You can go into the movies, go shopping, a restaurant, wherever you are. And when you get back, you'll hit the button on the key fob and the car will come pick you up. So I just wanted to show a couple quick examples visually of what's going on in terms of these types of situations and scenarios where visual computing is used inside the vehicle. We talked about Tesla as well. There's actually 2 of these modules inside the Tesla Model S. And what I'll do is, I know we're pressed on time, so I'm going to skip a couple of things, but I really want to focus now on the driver assistance and the safety part. We see computing really being a huge need in the car. Again, it's more cameras, more sensors appear on the vehicle. It's a huge amount of data that needs to be processed, and it has to be processed in real time. There's all kinds of user experiences that we're going to enhance, whether it's augmented reality, higher resolution screens, more three-dimensional graphics that really provide a great visual experience. Again, inside the Audi, inside the Tesla, you have Google satellite maps. So again, it makes it really easy to see exactly where you are with a glance rather than trying to decipher a cartoon-style map. Language processing, as you mentioned, is huge. And the big problem that we've been seeing lately is that there isn't the processing power available in the vehicle to actually adequately sense or decipher what is being said, as well as then process the context of that. So natural language processing is a huge area. And there's a bunch of from the team at Nuance here, and I think the work that they're doing and the fact that something like a GPU, a graphics processor, is being used to accelerate voice processing is pretty incredible. And then driver assistance, of course, is a huge area for us. That's one of the things I'm personally most excited about. The processing power that's required to handle all the sensors that are in the car today, we're still not there. Most of these self-driving cars, the trunk is just full of PCs. And obviously that's not practical moving forward from a cost perspective, from an energy consumption perspective. But I think that as we look at all these new algorithms, the work that's happening here at MIT and other research institutes and at the automakers, all types of new algorithms, a field called computer vision, where cameras are placed around the vehicle. And a camera is just generating dumb information, right? It comes in, it's really meaningless. But the computer and software, which is key, needs to interpret that picture, be able to identify an object, a person, another car, a child, an animal, and be able to then give that information to the systems inside the car to react, to respond, and then provide the right feedback to the driver, whether it's some kind of an alert, vibrating the steering wheel, or actually braking or steering. So again, it's a computer problem. The technology exists today holistically. The question is bringing it all down into a form factor that will fit inside the car and be able to be something that software-wise can continue to grow. And I think this is where we're going. It becomes all about the software. We develop hardware and software for these vehicles. Right now, the software piece is relatively small. It's still, by estimates, about 30 million lines of code, which far exceeds what goes into airplanes or space shuttles or things like that. The complexity in the car is enormous. And what we want to be able to do, though, is invest in that so that software becomes a way that the car is always fresh. And again, we see Tesla's doing this. If you're familiar with the fact that there's a modem in these cars, so it's one of a number of brands today that are connected, but they're the only ones really that are doing over-the-air updates. So as you sleep, new software gets downloaded into your vehicle while it's parked in the garage. And in the morning, new features might be in the vehicle. One example is when they first started shipping the car, again, it's an electric car, you would take your foot off the brake and nothing would happen. You'd have to press on the accelerator for the car to go. And most everyone here that's used to driving a combustion engine knows you take your foot off the brake and the car starts creeping forward. So they got a lot of feedback from their customers that this just didn't feel right. And through an over-the-air update, they added a feature to the car. So you went to a settings screen on that big touch screen, and you turned creep on. And when you did that, you took your foot off the brake, and the car would start creeping forward. It's a basic thing, really pretty simple for them to do. But the fact that none of their customers had to take the car in, it happened overnight in their garage, they were delighted. It was this incredible thing. The car got better after they had driven it off the lot. Since then, they've done about monthly updates, some things, little tweaks, some stuff they needed to fix, but they've added new features and actually made the car safer in some senses. In that, there was an example when several cars had fires by running over objects in the highway at high speeds, and the battery pack got punctured. So this was in the news quite a bit. What Tesla did was add an update that would raise the air suspension in the vehicle slightly at high speeds to minimize the risk of this happening in the future. So again, what seemingly could be a recall in the industry is now a feature or an enhancement that they're able to deliver to their customers. So finally, what I want to just touch on is how the GPU, the graphics processing unit, is being used to perform things like artificial intelligence and other forms of supercomputing. So search is optimized in the cloud using GPUs. We do natural language processing, as I mentioned. So figuring out what is being said, what's the intent, what's the context, and being able to return information to the driver. Machine learning, so the ability to actually train a system, how to recognize pedestrians, how to recognize deer, how to recognize bicyclists, is a very complex task that uses the GPU extensively. And then that object recognition, being able to happen in real time, is accelerated by all the parallelism. And as we mentioned here, we have the self-driving car. Again, I think it's quite a ways off, but the technologies that we're seeing that we're leveraging from the cloud, from workstations, and now down into this mobile device. So the types of processors that we were able to put in phones and tablets, we can now put into cars that can do all of this work directly. Thank you very much.
Thank you, Danny. I know I have a whole new respect for the Audi A3 that I just recently drove, knowing that your graphics package is in it, and it was quite a system.